I'll be covering a very introductory and basic session on data modeling. Before we start, I have expertise in major industry trends, including dimensional and relational data modeling, data warehouse designing, online transactional processing systems, Azure cloud computing, MSBI full stack uh, insight tools, which include SSRS, SSIS, and SSES. I have been working on data science project and big data system throughout. I'm currently working with Microsoft and for more than 5 years and serving Microsoft business to grow by providing them the influential insights. Earlier, I have worked with different IT industries and organizations including Persistent System Limited, Pfizer, Citibank. A bit details on my academics. I have completed MS in software engineering from BITS Pilani. Post my graduation from SRIT in electronics and telecommunications. I have recently done a data science diploma course from IIIT Bangalore. So with that, let's start with what we are going to cover. You can see these are the few very important topics that we're gonna cover to understand why we are here. Why do someone wants to choose to work on data models? Let's start with the first one. What is data modeling? What it is, and actually why do we need it? As you might already be aware, data is a very crucial part for any business to run. Data industries are generating data every second, every millisecond, and that data can help them to grow their business, to provide them some unhidden truth that they cannot see with their naked eyes. Data modeling is actually the way to help them to achieve that. With the help of data modeling, industries can actually understand the data, understand the patterns, understand what the data mean, the different attributes of the data talk with each other. And with that, they can actually take some very important business decision, change their strategy to grow more. So with that, data modeling is actually collecting the data from all the different sources in which data might be present, structuring it in a format that can be understandable by the different business to serve the business need. Understand more about what data, their attributes are related, how they are related to each other, and how they are actually talking. What is relational and dimensional modeling? So, as I said, data is very crucial part of any organization. Generally, in industries, they store data in two different formats. One is the operational data. The second one is data warehouse. So before understanding more about what is relational data models and dimensional data modeling, let's understand more about operational data sources and data warehouses. Operational data sources are actually the wheels of an organization to run. The users of it actually creates the data from which the organizations run their process and grow and get the revenues. Data warehouses on a different front watch the wheels of the business to run. So users run the wheels, like they create the customers, they sign them up, they sell products to them. However, on a different hand, on a second hand, the users of data modeling or data warehousing understand how the wheel is moving and what can be done to move the wheel faster by understanding the data. So, operational data sources are basically those systems in which we generally put the data in, we store the data, the transactional data coming from the business process itself. However, the second part, which is very crucial for any business to make this strategic decision, is the data warehousing, in which we take the data out take the data out to serve meaningful insights to the business that they can understand easily with their naked eyes. Coming to that, moving forward, there are there are a lot of types of data modeling that someone can do. But relational data modeling and dimensional data modeling are very crucial in any industry and are actually very famous. So, relational data modeling basically describes data in the form of how entities and attributes are related to each other. You get data from different sources. You structure it. You understand it. You understand their metadata. Then you kind of create visualization of that data in the form of how they are related to each other. You generally keep it in the most normalized form so that the transactional system which are gathering the data can store it in a better way. However, in dimensional data modeling, we store data in a form which will be very easy performant for the reporting or insights to get leveraged. In dimensional data modeling, instead of instead of focusing on how the data is being stored, we focus on how the data can be get from the databases so that it will help the business to see the insights as efficiently as possible. With that, I would like to touch more about explaining you what is data warehouses. So data warehouses serve the purpose of providing insights to the business. The data warehouses are subject oriented, integrated, non volatile, and time variant modeling systems. Let's understand more about it quickly. Data warehouses are subject oriented. That means they are created and designed to serve a very specific purpose. You have to understand the business process and what exactly your business users are looking to take the business decisions. Hence, they are very subject oriented. You cannot get all the data and create a single model on top of it until you understand the business process and what the leaderships or the key stakeholders of the business are looking to grow in their business. The second one is integrated. Data houses are very integrated system. As we all know, we are getting data from all different sources. There are, as we are moving towards the future, we have n number of possible sources from which we can get the data. Either they can be in text format, either they can be in CSV format, either they can be Parquet or some big data solutions, or they can be spread across multiple sources, databases. So data is spread. All the departments of the data have a different way of storing the data. So it's very important to collect the data from all these systems so that they can be placed in a single central repository. Third one, non-volatile. Data warehouses are created with non-volatile data. What does that mean is the data once comes in cannot be changed. The transactional data that we get from operational data sources and bring in data warehouses, these data are the source of truth. So in data warehouse, there is no mechanism, there should not be any mechanism to update the data or the change the data. So they are non-volatile. That means once the insights are served, it is rarely to change. Time variant. On the different time variant, what does that mean? It means is that they are flexible. Going to the next, components of data warehouses. Now we have a good understanding of data warehouse and the need of it. Let's understand what are the components of it. Data warehouse has majorly four components. One is the source itself from which we get the data. The second one is the staging area, wherein we keep the data. The centralized repository that I was talking about, that is the first phase of it, the staging area. Then we get the presentation area, wherein we have data in more structured format, which have a proper relationship with each other. By looking at the presentation area, one understand how data, the nature of the data, and how they are linked and are talking to each other. The fourth one is the access tools, which are very important. You can have the data, but is of no use until you have good access tools, good way to access it. So that is a very important stage of the data warehouse. Let me touch a brief about it. Sources, as I said, the discrete sources in which the data is stored. The staging area, dat- the first layer of the data warehouse, wherein all the data gets stored in a centralized repository. This is a very critical stage because to build a data warehouse or serve a meaningful insight, your data should be accurate. As people are already aware, because we have data stored in different format, there can be different challenges we might face respective to each source. So with the staging area, we hit on those challenges and try to solve that to make sure that our data is more accurate and can be relied by the business. The second one is the integration area or the presentation area. There we apply all the rules which are given by this business process or business stakeholders in terms of how the base data relates to the different business rules. The last one is the reporting tool or the access area. Once we have integrated area in place, we basically access it, create the visualizations on top of it so that it's very easy for the business to understand it and take the crucial business decisions. Coming to the next, dimensional modeling vocabulary. So the modeling is not created by one single person. People in the early stages when the data started to grow, people were already facing the challenges to handle those data and how that data can be collected to serve the important patterns and the business need. So so people at a different stages were working to solve this challenge, and hence as and when they started, they basically started to communicate in a different vocabulary. So at a standard stage, it was decided that when once the process got established, it was decided to create a vocabulary which can be communicated within all the data modelers, which are understandable and is standardized. So we have couple of vocabulary or terms that we use to communicate or represent our models, entities, relationships among the business and the team. Some of them are called in terms of dimensions and fact. So dimension and facts are very important parts of data warehouse or dimensional data modeling. I'll touch a brief about it because they are very crucial. Dimensions. So any source or any kind of a data has two things in nature. One is attributes, which has alphabets or words in it. And second one is the numeric values. Numeric values which can be additive or which can be measured or which can be used in some calculations and serve a definite business meaning in it. We call them measure. So dimensions are actually the master data of any organization or any business process. Dimensions are those fields which are used in the group by or in the aggregation or in the reporting labels by which we basically understand, slice, and dice the different measure of the business data. The second one is facts. Facts are actually the additive numeric data which are meaningful and results in some meaningful insights. They are the heart of the business data. With this, these are the common vocabulary term that we use in the data modeling world. Let's understand how do you create a data model? How do you approach to a business process? So at a high level, there are four steps that a data modeler has to perform. The first one and the very important one is to understand the business process. A data modeler should be very familiar with which kind of a problem he or she is going to target. For that, they have to very closely connect with the business stakeholder that perform the very important and crucial role in serving the business needs. A person who has a good understanding of the business process. Collecting the data, understanding is very difficult until you don't have clarity on how this data relates to a specific business problem. So the first step is to understand the problem with the help of understanding the business process that a data warehouse designer or a data dimensional data modeler will be solving. Once the business process and the problem is understood and is clear, the second step is to understand the grain of it. In the sense, how what would be the granular information the data warehouse will be storing or supporting, further which it cannot be segregated. Data warehouse to support a specific business need along with the granularity of it until which the further segregation of data is not possible. So again, in that, a close communication with the business and understanding of the insight that they are looking for is very important. They are the one who are going to tell us what grain or which kind of a data along with the summarized data they might be looking for to do or to predict or see the patterns of the existing data. So the second step to understand the grain of it. Once we understand the business process, once we understand the grain, like at which granular level our data warehouse is gonna store the data, the next step are the next step is to understand the dimensions. What are dimensions? Dimensions are the master attributes or the master data that's gonna be used in the aggregation or the labeling of our data, our numeric data. So all the master data which will be related to our data warehouse that will be which will be basically used to slice and dice of the different information is going to be decided in the very third step of the data warehouse designing process. The next comes is the fact designing, which means now understanding which all insights the data warehouse is going to serve to the business. The numeric data, how they will be stored, what will be the nature of it. Either they will be snapshot, they will be accumulated, or they will be additive. Understanding that, designing that is very crucial. So these are the very four steps that a data modeler performs to create a data warehouse. And very important to understand, these are all iterative things that data modeler do in the life cycle of a data warehouse designing. You have to keep refining your data warehouse. A data modeler has to keep refining their data warehouse over the period of time. Along with this, I would like to touch a very interesting topic, which is the myths that people have and the pitfall or the trap in which the data modeler generally get trapped. So the first and very important myth is that data models are generally the summary of data that is used to generate some canned report. No, not at all. Data models are not the summary of data. A data modeler has to understand that they gonna need to support the business to give the detail of the data so that they can run their queries on top of that data to understand more about that insight which has been presented at a more summarized way. The second myth: data warehouses are departmental, they are not enterprise. No, not at all. Data warehouse are actually there to serve the end to end insights of the organization. They are not departmental. They are basically designed to cross connect the different departments so that a business process between those departments and the data can relate to how these two departments are running together. So a good data warehouse is to serve is supposed to serve the end to end insights of an organization, not per department. They can be extended. The third one is data models are not scalable. Once they are created, they're not scalable. No. The data warehouses are supposed to be scalable in terms of how the business is changing and in terms of how the business stakeholders are looking for the insights to be lit up by your data warehouse. Covering the very interesting myths of the data warehouse, let's understand the pitfall a data model or data warehouse designer should avoid. The first one is overwhelmed with the technology than the business process. This is a very common trap a data warehouse designer might get into. As we talked about, data warehouse is more in terms of surfacing the insights to the business. So as soon as the business stakeholders are looking at the insights, the reports, the summary of the data, they will be able to make the business decision early, irrespective of how the underlying technology, the design, the performances. Obviously, performance is important to some extent, but one should never overspend the energy. Data model, a warehouse designer should always think about solving the business problem rather than being overwhelmed with the technologies. If collecting the data in an Excel, surfacing it to the user, modeling it within Excel, surfacing it to the business suffices the need. That is the best way a data modeler should do, rather than going through the tech depth of it and being overwhelmed with the technologies. The second trap a data modeler can trap into with the design is investing more energy in terms of normalizing the data at the back end or concentrating on the performance at the back end, then building the viable presentation area. So as we talked about, there are four layers in the data warehouses. Presentation area and the access tools are more important to the business. There can be cases in which the data warehouse designer can be trapped in the integration of the data than designing and building a performant application and integration area to the business. So for the front layer, which is accessible to the business, should be more performant than the first two layers. The third trap, more attention to the back end than the front end with respect to performance. The next one, neglect to acknowledge that the success of data warehouse is based upon how the business is consuming it. No matter how well you design a data warehouse, no matter how performant your data warehouse is, if it is not being used by the business, it is of no use. So a data warehouse designer should be very cautious about what exactly a business is looking into, so that the data model or data warehouse should suffice those requirements rather than being overwhelmed with the technology, with the data, and with the design. So these are the common dimensional modeling myths and pitfall that a data modeler should avoid for sure. Going to next, there are other things which are very important and are industry driven, which will be needed for a data modeler to perform. So with this course, we will be covering a day-to-day business problem solving and the very basics and advanced fields of data modeling, which will include basics, data modeling overall process, notation, schema types, data modeling types, dimension types, what are the fact types, fact table, relationships, data modeling standards, dealing with the hierarchy information, data modeling, further informations, how the reports are designed on top of data model, and some practice test and interview questions. There are other add-on topics that can be leveraged post this data modeling course to basically jump or join the latest trend in the current world which relates to data. With the by taking this course, you can basically proceed your career in in further technologies which include analyzing data with Power BI. Power BI is the most demanding tool of data visualization. Microsoft Technology Associate, Azure Data Fundamentals, which is basically the cloud computing, which is very trending in the current world. Implementing data solutions on cloud, fundamentals of data visualizations using Power BI. So these are the certain areas in which you can basically explore your career and extend with the help of this course. There are additional course resources that you can learn to understand more about it. Data Warehouse Toolkit by Ralph Kimball and Marguerite Ross. This is basically the Bible of data warehouse and data model designing. I would highly recommend a data modeler or data modeling aspirant to go through this book. Data Warehouse Fundamental by Oracle also serves a good insights and practices on data model designing. Data modeling tools. What are the tools that a data modeler should be familiar with to make their day-to-day life more impactful and easy? Data Warehouse in Real World by Sam and Horry and Dennis Murray. This is another book which has a good case studies solving some of the very basic industry problems. In this course, we will be solving good projects. So knowledge is not useful if you're not able to apply it in a real world problem. So in this course, we will be covering very interesting and common problem that industries has and how they solve it, how they approach to solve it with in the dimensional modeling field. We will be covering 3 projects and we might cover other projects as well. The very first one is retail case study, a very basic case study, wherein we will be designing a data model solution for a large grocery chain, which collects data from different POs, vendor delivery data, and using a built-in solution to maximize profit. How, for this organization, we will be creating meaningful insight by creating a good data model that will serve the organization to understand their process more and take some very good business decision out of it. We will be solving another case studies for procurement process of an organization, wherein we will be designing a data model for the demand trend, raw material procurement, and vendor performance for a very large organizations. HR management. This is also a very critical department of any organization. We will be solving one case study for HR department as well, wherein we will be designing a data model solution for human resource management team, which deals with common cross-industry business applications and supporting rapidly changing competitive business environment. Understanding employees demographic, skills, earning, performance to maximize and the impact, and the more importantly, the chances of how HR can understand the very common problem or the requirement of a business process, like how the skills are, how the employees' performance in an organization is going on, what are the chances they might need to recruit other people, what are the chances their existing employee might might resign. So these are the very common problem that HR department face. We will be creating a data model to solve these kind of a day-to-day challenges for human resource department of an industry. Coming to the next, as we saw, we will be covering some of the good industry problems. We will be setting up the lab and doing the hands-on. For that, these are the prerequisite that someone should have. One is good, the very important, high network speed, a laptop or a desktop. Microsoft Windows 7 or above, 500 GB of hard disk, at least 6 GB memory, and 4 core CPUs. Apart from that, there are other softwares or apps you might need. We will be Apart from this, we will be providing some mock interviews after completion of this course so that participants who want to evaluate themselves before applying to a job can acknowledge the gap and work towards it. We will be supporting in that area. There are some certification which applicants can consider to apply for post completion of this course. One of them, which is very famous, is implementing data warehouse using SQL. Oracle also provides a certification on data warehousing. Microsoft provides two certification in that area, implementing data models and report with Microsoft SQL Server. After course completion, you will get a certificate from MindMajix on your achievement. Thank you. Thanks for attending the session. Please share your feedback or you can contact us for the further queries related to course, scope, schedule, references, cost, payment option. You can see the email highlighted in the PPT, info@mindmagix.com. We have the contact information for India and USA as well. Please feel free to call us and we will be helping you with the further details. Thanks for joining.